Now, the most powerful military on the planet is amassing at the doorstep of Iran. One aircraft carrier has been deployed, another is being floated towards the region. Waves of fighter jets, guided missile destroyers, a naval armada of historic scale are circling. Now, 2 rounds of talks between Iran and the United States have failed to find any kind of common ground, but inside Tehran's closed rooms, the strategists are running a very different kind of a calculation, because if talks collapse and the missiles start flying, then Iran has only one window.
What does it look like when a military operation fails in real time? Not because of bad soldiers, but because of bad math. At 10:30 a.m., 10 Iranian coastal batteries opened up simultaneously on the USS Abraham Lincoln strike group. Gun crews were disciplined, reload cycles were tight, around 30 seconds per gun, and the barrage was coordinated across 15 miles of coastline. And every single shell splashed into empty water, 5 to 7 miles short of the ships. The crews knew it immediately. So did the command. What happens next is the part nobody talks about. These crews weren't guessing. For weeks before the engagement, Iranian artillery planners were running detailed firing solutions across all 10 battery positions. Each gun sat inside a reinforced concrete bunker, spread out across a 15-mile stretch of coastline, and the crews were doing real work.
So what the president has been very clear with the Iranians, and actually I just talked to Steve Witkoff and Jared Kushner this morning about some of their negotiations, is the United States has certain red lines.
Calculating range tables for different distances, adjusting for wind speed, air temperature, altitude, and small shifts in atmospheric pressure that actually change where a shell ends up. That last part matters more than people realize. A 155mm shell doesn't fly flat like a bullet. It goes up steeply, climbs several thousand feet, then comes back down on a long arc. Every variable along that arc, wind pushing sideways, temperature changing the air density, humidity affecting drag, all of it shifts the landing point. So you can't just point and shoot at distance. You have to do the math, and these crews did. The problem wasn't the math. The problem was what they plugged into it. Every firing solution they built was based on an assumed target position. They expected the Lincoln's carrier group to move into a specific zone, around 28 miles offshore, because that's the edge of what their guns could reach. So that's the distance they solved for. They built firing tables around that number, pre-positioned their ammunition loads, coordinated timing across all 10 batteries, and sat ready to fire the moment the ships entered that window. A firing table is really just a lookup system. You know your gun, you know your shell, you know your powder charge. So for any given distance, the table tells you what elevation angle to set the barrel at. It's accurate, and these tables were well prepared. But the table is only right if the distance you're using is right. Feed it the wrong distance, and the barrel angle it gives you is wrong, and the shell lands somewhere it wasn't supposed to.
Live now from Fox, I am Andy Mack. Day number 11 of this ongoing conflict in Iran. And although President Trump has said there are no reports of mines being placed in the Strait of Hormuz, those threats, those just reports are causing issues with this major energy artery there. And you can see this from Central Command saying the forces, they have eliminated multiple Iranian naval vessels, including 16 mine layers near that Strait of Hormuz.
At the outer edge of a gun's range, that error gets worse fast. You're already asking the shell to travel as far as it physically can. A small error in distance doesn't produce a small miss. It produces a big one, because the shell is running out of energy right at the end of its flight. Any extra distance it needs to cover, it just can't make. The Lincoln wasn't at 28 miles. It was sitting at 35 miles offshore, 7 miles farther than every single firing solution assumed. The crews had spent weeks solving a problem, and they'd solved it perfectly for a ship position that didn't exist. So at 10:30 a.m., all 60 guns opened up at once. The shells flew exactly the trajectories the tables said they would. The barrel angles were set correctly for 28 miles. The powder charges were right, the timing was tight, and 300 shells landed in open water, 5 to 7 miles short of anything. From the coast, crews could see the splash columns going up. On the command network, controllers were watching impact points appear on their maps, And those points just formed a line. A very clear, very expensive line that showed exactly where the shells were falling and exactly how far short that was. 300 shells and the whole barrage just drew a picture of the gap. So let's take a look at how the Lincoln knew to stop at exactly 35 miles, because that decision didn't come from nowhere. 35 miles wasn't a round number somebody picked off a map. Radar operators aboard the Lincoln had been watching that coastline for 48 hours straight, and what they were seeing wasn't normal.
Our primary interest here is we don't want Iran to get a nuclear weapon. We don't want nuclear proliferation.
Iran is digging in. Supreme Leader Khamenei fires back with a chilling pledge. Iran's arsenal includes weapons capable of sending American warships straight to the seabed.
Radio traffic between the 10 battery positions was spiking. Satellite imagery from that morning showed crews moving equipment around, adjusting gun emplacements, running what looked like pre-fire checks, and doing it across all 10 sites at roughly the same time. That last part is what flagged it. One battery doing maintenance is routine. 10 batteries doing coordinated pre-fire checks simultaneously is a picture. And American naval planners were reading that picture in real time, adjusting the carrier group's threat assessment hour by hour as new information came in. Here's what the intelligence gave them. The 155mm guns at those coastal positions had a known effective maximum range of around 28 miles under standard conditions. That number came from radar profiling, signals intercepts, and existing data on the specific gun systems Iran was operating at those sites. So the Lincoln's planners took that 28-mile number and added 7 miles on top of it, which put the carrier group at 35 miles offshore and just outside the Iranian gun's reach. 7 miles sounds like a comfortable cushion. It really isn't, not for a carrier group.
Well, we have different styles of mine, and I think one of the things that a lot of people are doing is looking at kind of old-fashioned ones they've laid back in the 80s and the 90s, the kind of the traditional, big, huge floating ball with the horns on it. That's the kind of your traditional contact mine. But in truth, mines have changed, much like we've seen mine warfare change on land. Much more sophisticated bottom mines, very difficult to detect, made out of composites, mines that actually move, almost like drones.
The Lincoln itself is over 1,000 feet long, and it's traveling with 4 escort destroyers. You can't just gun the engines and sprint sideways if something goes wrong. So holding at 35 miles was a calculated decision based on specific intelligence about specific weapons. Not a cautious guess, not a wide safety margin. It was tight, and the planners knew it was tight. By the time the barrage started at 10:30 a.m., the ships weren't scrambling. Defensive countermeasures were already active. Damage control teams were staged and ready across the fleet. Medical personnel had pre-positioned treatment areas on each ship. The Lincoln and its escorts were just waiting, fully set up, for something they already expected was coming. So when 300 shells started landing 5 to 7 miles short, nobody on the American side was surprised. The splash columns were visible, the impact points were showing up on tracking screens, and the pattern confirmed exactly what the intelligence had predicted. The Iranian guns couldn't reach them. The 35-mile standoff had worked. What happened next on the Iranian side is where it gets pretty revealing. Battery commanders, watching their shells fall short, started pushing their guns past standard operating parameters. Crews cranked barrel elevation up to the absolute maximum angle the guns could physically achieve. Powder charges got bumped beyond standard loads to push muzzle velocity higher. Some crews pulled out windage corrections entirely, basically gave up on accuracy and just tried to squeeze every last foot of distance out of each shot. It helped a little. Some shells started reaching out to around 30 miles. But 30 miles is still 5 miles short of the carrier group, and field modifications on a gun that's already at the edge of its design limits just don't close a gap that size. The physics don't bend that way. By 11 a.m., roughly 30 minutes after the barrage started, ammunition stocks at the batteries were significantly depleted. Gun crews were exhausted. Each 155mm shell weighs over 90 pounds, and they'd been handling them on a 30-second reload cycle. The radio traffic across the Iranian command network was showing the same story from all 10 positions. 300 shells, 10 batteries, weeks of real work. And it all failed because of one wrong number. The target position was off, and everything built on top of that collapsed the moment the Lincoln held at 35 miles.